Welcome to this session on IEC 62353. This is the international standard that governs recurrent and post-repair electrical safety testing of medical electrical equipment. So think of this standard as the opposite or the counterpart to IEC 60601, whereas IEC 60601 focuses on type testing before a device actually goes into the market. What IEC 62353 is, it deals with what happens afterwards. So in hospitals, clinics, and repair shops where devices are used and maintained daily. This standard was introduced in 2007 and updated in 2014 to address the need for a consistent, safe, and practical framework for in-service testing. The idea is to protect both the patients and staff while ensuring the equipment remains functional without damaging the equipment by using overly harsh laboratory style tests. So in this session, we'll unpack the main elements of the IEC 62353 and compare it to also IEC 60601, so you guys get a better idea of the two standards. We're going to explore testing methods like equipment leakage and applied part leakage, and also discuss some practical applications, some pitfalls, and some future outlooks as well with these standards. So by the end, you'll not understand not only the technical details, but also the philosophy behind the standard. So let's dive in and explore why this matters so much in the context of modern healthcare and biomedical engineering. Why does electrical safety matter so much in the context of medical device? So at the most basic level, it's about protecting patients and healthcare workers from harm. Medical devices are often in close contact with vulnerable patients, right? So sometimes they're sometimes invasive, they're sometimes life sustaining, and even a small leakage current can cause injury or worse. But the thing is, safety goes beyond the patients. Staff working with these devices every day, they need to trust that the tools they're using won't compromise their own health. And what does this relate to IEC 62353? It just creates a reliable way to verify that safety. It makes sure that the device itself remains reliable, that it may power on, and the thing is, you can't always be sure it's operating safely under fault conditions. So what IEC 62353 does, it makes sure that it's still working even after it ends with the production line and before the device first enters service. So hospitals can compare the ongoing results directly to the measurements that it was done in the factory. In short, electrical safety testing matters because it safeguards people and preserves trust in healthcare technology. So what exactly is IEC 62353? So at its core, it's a framework for recurrent tests and tests after repair of medical electrical equipment. The standard came about because IEC 60601, the type test standard, was too complex and sometimes unsafe to apply outside a lab. IEC 62353 defines the set of practical, repeatable tests that can be applied during routine maintenance or inspections or after repair. So one of its key innovations is how it addresses the dielectric integrity through two main leakage tests: equipment leakage, which looks at the total leakage from the mains into the equipment, confirming the means of operation protection, otherwise called as MOOP, and also applied part leakage, which ensures that the floating applied parts, so think of BF and CF type connections, remain at safe levels, confirming the means of patient protection, MOPP. These tests help confirm that the safety barriers inside the device are still intact after they've left the factory. So IEC 62353 adapts to this. It gives us field service engineers the tools that work in the real world environments, not the lab conditions, without compromising safety. What is the scope of IEC 62353? So the scope is that it applies to in-service medical devices, the devices that are already being used in hospitals and clinics, but as well as equipment that's already been repaired and needs verification before going back into use. What does this test cover? They cover the basics of electrical safety. So insulation resistance, protective earth continuity, and different types of leakage current. But there are some critical differences from IEC 60601. First difference is IEC 62353 avoids destructive tests that could damage the device. Things like high voltage dielectric testing that aren't part of the routine. Second, there's no preconditioning of equipment. There's no artificially elevated mains, and tests are performed under single fault conditions only. The focus is on ensuring ongoing safety without introducing unnecessary risks. Another major part of the scope is frequency. So if you've read the 2014 edition, it suggests that following the manufacturer's recommendations, but if those aren't available, a risk-based interval of 6 to 36 months is recommended, depending on the device's use, environment, and risk profile. Overall, the scope is very broad, and it's enough to cover most of the equipment, but flexible enough to be applied consistently across different healthcare contexts. When it comes to the actual testing methods, IEC 62353 defines several. Visual inspection always comes first. We check the cables, the housings, and the connectors for wear and damage. Then after this, we check the protective earth continuity. We make sure that the grounding is always intact. And with insulation resistance testing, it's optional, but it is recommended. Applied part leakage test check, that floating applied parts like BF and CF types, they remain safe for patients. The standard also allows different test methods: direct, differential, alternative. They're not as harsh as type tests, but they are robust enough to reveal when a device is unsafe. So what are these in real practice? So I want you to imagine a hospital running a safety check on infusion pumps every year. So under IEC 62353, the engineers would inspect each pump. They would run continuity and leakage tests, and then they would document the results. If a pump fails, it's taken out of service until repaired and tested. The same goes for ventilators or monitors after servicing. Before going back to a ward, they're tested against IEC 62353 to make sure they're safe. Manufacturers are also increasingly applying IEC 62353 at the production line stage. So the baseline measurement hospitals can take later can be directly compared with the factory results. And any discrepancies or drift from the leakage current becomes immediately visible. And what's the purpose of this? It creates a chain of safety checks from the factory to the front line, which is the hospitals and the clinics. And rental companies can rely on these tests, before shipping a device to a hospital. So it creates a reference. And just in practice, the standard saves time because it avoids any destructive tests. What are the benefits of this? It allows more time for engineers to also do functional and visual checks, which are equally important but often overlooked, right, when the time is right. No standard is perfect, of course, and the most common pitfalls do arise with IEC 62353. One of the biggest mistakes is engineers misapplying IEC 60601 procedures when they're actually supposed to be using IEC 62353. For example, expecting elevated mains or preconditioning can cause confusion. Remember, the goal is safety, not blindly following a checklist. So keeping that mindset helps avoid pitfalls and make sure IEC 62353 testing adds real value. If you're responsible for compliance, here are a few practical tips. First, always use testing equipment that's designed for IEC 62353. Many modern electrical safety analyzers have built-in routines for it. Second, don't skip the basics. Visual inspection most of the time reveals the issues before any electrical test does. And thirdly, remember that insulation resistance tests, while optional, can provide valuable insight. But only run them if the manufacturer confirms. So always check the service manual, making sure that it won't damage the device. What is the future outlook in medical device safety? So looking ahead, IEC 62353 is likely to evolve alongside healthcare technology. One clear trend is efficiency. Hospital and service providers want faster testing now without sacrificing accuracy. That means more analyzers will integrate automated IEC 62353 routines. So what this will do is it will sync directly to the asset management system wherever you're using, and this can reduce paperwork and human error. And now, perhaps with the evolution of AI, AI and data analytics could spot patterns in leakage or continuity results before they become failures. So just imagine being able to predict that a ventilator will fail its next safety test and service. And you can service it proactively. The standard may also expand on emerging technologies like connected devices that introduces new leakage pathways through data ports. Ultimately, the outlook is about smarter, more connected, and more consistent safety practice. To wrap up this video, IEC 62353 is more than a technical standard. It's a philosophy of safe, practical, and efficient in-service testing. So it makes sure the devices remain working throughout their life. And for biomedical engineers, for clinical technicians, and manufacturers, adapting IEC 62353 means fewer risks, clearer results, and a consistent framework to rely on. So the call to action is simple. Embrace IEC 62353 as part of your maintenance routine. Use the right equipment, document thoroughly. You'll actively protect patients, staff, and the integrity of medical technology itself.